Okay, we are back. This is Techmath1. We're looking at chapter 14, and we're going to do just one problem from 14.4, and that's going to be number 18. So they describe a real-world problem. Various technical problems involve solving systems of three equations. The system below was set up to find the forces in kilograms on a steel beam. So we're doing some structural engineering here. For you future structural engineers. So let's take a look at these forces on a beam. So this has already been calculated, and we want to find force 1, force 2, and force 3. All right? Now, we are not going to do the addition method where we get something to go away like by hand and fill up the whole board. What we're going to do is we're going to use our calculator. We're going to put this into a matrix. That means you strip away just the coefficients, 3, 5, -2, and 1600. And this is called an augmented matrix because you've got the matrix part here and then the answer part all in the same matrix. This is 1, 1, -2, and 0 in the answer column. And then 2, -3, 4, and 500 in the answer column. And so what we're going to do is we're going to enter this into our graphing calculator. We're going to do reduced row echelon form. All right, and that's going to give us 1, 0, 0 answer, 0, 1, 0 answer, and 0, 0, 1 answer. So it'll give us X, Y, and Z, or in this case, F1, F2, and F3 will happen right there, there, and there. Okay, this means 1F plus 1F1 plus 0F2 plus 0F3 equals whatever the answer is. So let's find the answer. So we're going to go from our calculator, second, and then the X to the -1 button is matrix. All right. And now it says names, math, and edit. We want to go to edit a matrix. And again, if you want to put it in, I just keep putting it in overwriting A. If you want to, here, let's show you. You can click down to another one if you want to keep old ones. And then you hit enter. And now it says matrix B. What do you want? A 1 by 1? We do not want a 1 by 1. We want 1, 2, 3 rows. So that's the first number is 3 rows. And then click it to the next one, 4 columns. Then you hit enter. And now look, it populates it all with zeros, but we're going to put in 3 and then hit enter, 5, enter, -2, enter, 1600, enter. Okay, 1, enter, 1, enter, -2, enter, 0, enter. 2, enter, -3, enter, 4, enter, 500, enter. All right, and you can look it over. You can kind of scan through it with the arrows and make sure you got all the correct numbers in there. Now we want to quit out of here. So you go second and then mode, that's quit. All right, we're back to the home screen. Now off of the home screen, second matrix, and this time instead of edit, we go to math. That's 1 over, and then you click down until you see reduced row echelon form right there, RF. And hit enter, and now we want it for matrix, and I put it in B, so we're going to go down to B, and then hit enter, and then hit enter. And there's our answers. So the forces on these beams are 200, 300, and 250. And so if we want to formalize it, if you want to take it out of here, F sub 1 is 200, F sub 2 is 300, and F sub 3 is 250. And that is definitely the way to do it with your technology. That was in kilograms. Force in kilograms, okay? Okay, so I will talk about 14.5 and 14.6 and 14.7, but we are not going to do these problems because it's just a long drawn out way of doing what your calculator does with reduced row echelon form. This augmented matrix is the way to go. Trust me on this, okay? If you didn't have a calculator at your disposal, you might want to be doing this, all these Kramer rule things and doing these things by hand. So 14.5 is system of 3 formulas where you're taking and subbing in 2 formulas into a third formula to get rid of different variables that they pick. You won't have to do that on the test, so don't worry about that. And then 14.6, it's third order determinants. And so that's when you're finding, remember we did those 2x2 determinants when it was just 2x2, when it was just a 2x2 matrix. We multiplied diagonally down and wrote it down, multiplied diagonally up and wrote it down, and subtracted those two. That was the determinant. To do a 3x3 determinant, it is a little more complicated because you got to multiply down this diagonal, but then you got to rewrite these 2 columns over here so you can multiply the second one down and the third one down. So go down, 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 multiply all that, add them together, put down the number, and then you multiply up, up, up 3 times, multiply them all, add them together, and then subtract it. That's how you find the determinant. And it's very tedious. We're not going to do it that way. Again, if you didn't have a calculator at your disposal, or a graphing calculator, yeah, then I would do Kramer's rule and do it that way. And so like way back when I was doing my undergrad and I had an undergrad matrices class, we didn't have graphing calculators. And so we did this by hand like this. You can look at, some of the examples they did for you. It's a big process, but at the end of the day, when we're doing reduced row echelon form, it's doing it instantaneously. And so it's less likely that you'll mess up something, accidentally add something where you were supposed to subtract or multiply wrong or something. So, and then 14.7, the determinant method, that's back to Kramer's rule. We did that. I demonstrated that with a 2x2. I don't expect you to be able to do that with a 3x3 like this. Again, if you didn't have a graphing calculator, this would be a way to do it, but it is quite a process. It's like a page of work to get one problem knocked out. All right, and that is it for chapter 14. So reduced row echelon form, woohoo, go graphing calculator. We can use that for our 3 variable matrices.